Automatic. Addison.
In this tutorial, we will install ROS2 Jazzy. By the end of this tutorial, you will be running your first ROS2 programs. Let's begin by installing ROS2 Jazzy via Debian packages. Debian packages are software files used to install programs and applications on Ubuntu. Open a terminal window. Type this command inside the terminal window. Locale. L-O-C-A-L-E. A locale is a set of variables that define the language, country, and character encoding settings. These settings are used by applications to determine how to display text, dates, times, and other information. Now type the following command: sudo apt update and the and symbol, the two ampersands, and then sudo apt install locales. Sudo apt update updates the package index list. This list is a database of all the software packages available for your version of Ubuntu. Sudo apt install locales installs the locales package, which provides support for different languages and regions. Now type the following commands into the terminal window to generate locale definition files. After each command, press Enter on your keyboard. Sudo locale gen, and then in us.utf-8. You can see this command on your screen. Now type sudo locale lcall equals in us.utf-8 lang equals en_us.utf-8. And then type export lang equals en_us.utf-8. Again, the commands are written on your screen. In this case, these commands are generating locale definition files for the English locale and the English UTF-8 locale. The UTF-8 locale is a special locale that supports the UTF-8 character encoding, which is the standard encoding for most languages. Now we need to verify the settings by typing locale, L-O-C-A-L-E. Here's what you should see. Let's add the ROS2 apt repository to our system. apt, APT, stands for Advanced Package Repository. This repository provides a convenient way to install and manage ROS2 packages without having to clone packages to your computer from GitHub and then build them from that source code. Open a terminal window and type the following two commands: sudo apt install software properties common. Sudo add apt repository universe. Again, the commands are written on the screen. Now press Enter. The Software Properties Common package provides a number of tools for managing software sources on Ubuntu and Debian systems. The Universe repository is a software repository that contains a wide variety of software packages, including many that are not included in the default Ubuntu and Debian repositories. Now we need to add the ROS2 GPG key with apt. The ROS2 GPG key makes sure the software packages you are installing are from a trusted source. Type these commands: sudo apt update and sudo apt install curl-y. Now you're going to type this big command. You can see it on your screen. Sudo curl, the hyphen SSL, and then all of that GitHub user content URL. Add the repository to your sources list. Write that entire command right now. Pay careful attention to the spacing between characters. Go slow. Remember, slow is smooth, smooth is fast. The old Navy SEAL mantra. You're always better off going very, very slow and doing it right than going very, very quickly and doing it wrong. Now type the following command to install ROS2 development tools: sudo apt update and sudo apt install ROS-dev-tools. Upgrade the packages on your system to make sure you have the newest versions. Type sudo apt upgrade and then -y. Now, for the fun part. Here is where we finally get to install ROS2 Jazzy. Open a terminal window and type this command: sudo apt install ROS Jazzy desktop. Again, sudo apt install ROS Jazzy desktop. Sudo apt install ROS Jazzy desktop. You're going to install ROS2 Jazzy. Once Jazzy has finished installing, you need to set up the important environment variables. Environment variables are settings that tell your computer how to find and use ROS2 commands and packages. Open a terminal window and type this command: echo quotes source /opt/ROS/jazzy/setup.bash quotes, and then the two little arrows, the tilde symbol, /bash rc. Pay particular attention to the spacing in that command. By adding this line to your bash rc file, you ensure the necessary environment variables and paths for ROS2 Jazzy are properly set up each time you open a new terminal window, allowing you to use ROS2 commands and tools without having to manually run the setup.bash script every time. For the changes to take effect, you now need to open a new terminal window, or you can use this command in the current terminal: source space and then the tilde / .bash rc. To verify that line was added, type sudo apt-get install get and then the hyphen and then y. And then open the bash rc file by typing get tilde / .bash rc. Close the get window. Now, how can you tell what ROS2 version you are using? Well, it's this command. Type print inv ROS_distro. You should see Jazzy. You can also type inv, so env, and then the space, and then the pipe symbol, and then the space, and then grep, grep, space, and then all capitals type ROS, ROS. Finally, you can also type echo, space, and then the $, and then capital ROS underscore, and then distro, DISTRO. Now set up the system to manage ROS package dependencies by typing sudo rosdep init. Now type rosdep update, ROSDEP, and then space, and then update. Let's install some other useful packages like pip, the Python package manager, Gazebo, a simulation software tool for robotics, and NumPy, a scientific computing library for Python. Type these 3 commands: sudo apt-get install python 3 pip space -y. Sudo apt-get install ROS $, open bracket ROS_distro, closing bracket, -ROS -GZ space -y. Now type sudo apt-get install python 3 -numpy. If you want to run an example Gazebo simulation world now, open a new terminal and type this big, nasty command: libgl always software = 1 qt qpa platform xcb gzsim -v 4 shapes.sdf. You can see the command on your screen. Type all of that into your terminal window now. These environment variables help you avoid a nasty error which happens by default when you try to launch Gazebo from a fresh ROS2 installation. So that's why we need that big libgl always software environment variable set from the outset. Now close Gazebo by going to a terminal window and typing Control C on your keyboard. Let's make these environment variables permanent. Open a terminal window and type these commands, one after the other. Echo, single quote, export, and then libgl always software equals 1, and then a single quote, and then the two arrows, and then tilde / dot bash rc. Be careful with the spacing there between the different parts of that command. Now do echo, export, and then the qt/qpa platform xcb command. Now source the bash rc file. You're going to do that a lot over the course of your ROS2 career. Now test your Gazebo installation again by typing the following command, gz space sim. You should see this screen. Click on the NAO Joint Control Simulation and click Run. Close the simulation by typing Control+C in the terminal window. That's Control. Hold down the Control button and press C. Now try the Panda Joint Control World. Type GZ and then space and then SIM, S-I-M. Click on the Panda Joint Control World simulation and click Run. It might take up to 60 seconds to load. Just be patient and don't quit Gazebo if you're asked to quit. Close the simulation by typing Control and then C on your keyboard. Remember, you're going to hold down Control and press C on the keyboard while having the terminal window highlighted. Now let's run another example. Type gz sim shapes.stf -v and then 4. Close the simulation by typing Control-C in the terminal window. Now let's run the same shapes example using a ROS2 command. We're now ready to dive deep into ROS2. Type ROS2 launch ROS underscore GZ sim, gzsim.launch.py, that gzargs, and then shapes.sdf. Type all of that into your terminal window now. Close the simulation by typing Control C in the terminal window. You're going to do that a lot too over your ROS2 career. Now that we've tested Gazebo, let's test our ROS2 installation by running some sample programs. Open a terminal window and type ROS2 run demo nodes cpp talker. So that's ROS2 space run space demo underscore nodes underscore cpp talker. This command runs a pre-built program called Talker that comes with ROS2. The Talker program publishes messages to the ROS2 system in string format. Open another terminal window and type ROS2 run demo nodes py listener. If your output looks similar to what you see on the screen, you have installed ROS2 successfully. To close these programs, press Control C on your keyboard in both terminal windows. So what did we just do here? And what do these two Hello World programs we just ran have to do with real world robots? So imagine you're building a robot that needs to navigate through a room. The Talker program is like a sensor on the robot, so a depth camera, for example, that constantly sends out information about what it sees. The Listener program, on the other hand, receives the information that was published by the Talker program. This Listener program in a real robot could do something with that data, like stop the wheels if an obstacle is detected by the camera. The Talker program is what we call in ROS2 a publisher. Remember that, publisher. You're going to use that word a lot over the course of your ROS2 career. The Listener program is called a subscriber. Remember those two terms. Those are the two most important terms in all of ROS2. Publisher, subscriber. A ROS2 publisher sends data, a subscriber receives data. In future tutorials, we will create our own publishers and our own subscribers for actual robots. Publishers and subscribers are the bread and butter of ROS2. They're the main way programs exchange information with each other inside a robot. So again, just remember this. Publishers are programs that send data to other programs, and subscribers are programs that receive data from other programs. All these programs are usually written in either Python or C++. Collectively, publishers and subscribers in ROS2 are called nodes. Remember that, nodes, N-O-D-E-S. That's probably the third most important term. No, not probably. It is the third most important term in ROS2. You just saw how to run a publisher node named Talker and a subscriber node named Listener. The term node is the third most important term in all of ROS2. Just remember that. Publisher, subscriber, and node. So remember these terms. You'll be using these three terms again and again and again and again and again over the course of your ROS2 career. To close out this tutorial, let me show you a cool program that enables you to show multiple terminal windows in a single window. This program is called Terminator. Not that Terminator, but Terminator for Linux. Open a terminal window and type sudo apt-get install Terminator and then space and then that -y. That -y at the end, that means yes. Because if you don't add that, it's going to ask you, would you sure you really want to install this package? But yeah, we want to install it. So just make sure you add in that -y at the end. Now, once you finished installing, you need to type Terminator. Right click on the screen and click Split Horizontally. You can also click Split Vertically if you want to have that kind of format for your panels. On the top panel, type ROS2 Run Demo Nodes CPP Talker. On the bottom panel, type ROS2 Run Demo Nodes Pi Listener. Now press Enter in both terminals. Here is what you should get. Press Control C in both terminal windows to close everything. That's it. Keep building. I'll see you in the next tutorial. Thank you.